Welcome to the lecture series of network analysis or electric circuit analysis. Today I am here to discuss the fundamental aspects of circuit analysis, what is the meaning of a circuit, what we are going to analyze about the circuit, and how this circuit analysis is useful for us in understanding the system. So, when we build any system or when we design any system, it is a obvious requirement that we need to understand the system, and to understand the system there are various stages. We can understand the system with physical operating parameters or physical performance parameters, like build a system, make it work physically in real time, observe the operations, observe the outputs, note down the readings and analyze the output, or draw the inferences about the system that we generally do in our practicals. Okay. But it is not possible every time for us to know the system performance only by going through the real time operation or physical model. So, most of the time we need to operate at the time of design, we need to understand the system by varying the performance parameters of a particular system. For a electrical system, the circuit elements or the performance parameters are like current, voltage, power, energy, frequency, phase angle. Okay. The passive element values like resistance, capacitance, inductance, active element values like voltage value of a voltage source, current value of a current source, and etc. So, if I want to know all these things, or if I am interested to know the current or voltage in any particular branch, then the circuit analysis will be very much useful, or the circuit study will be very much useful, wherein we will be applying various techniques to understand or to know what are the voltages, currents and various other quantities that are existing in a system physically, but which can be obtained or which can be known through the mathematical tools. So, circuit analysis or network analysis is one such subject which will deal with such methods and tools, wherein we use these all methods and tools to know the circuit behavior or to know the system behavior through circuit behavior. Okay. So, here first we will look what is a circuit. Directly coming to the point, to the electric circuit. See, circuit can be of anything. It can be a hydraulic circuit, it can be a circuit that connects so many irrigation systems. Okay. It can be an electric circuit. Okay. So, basically a circuit is a closed system where a particular task is done or some kind of work is done to achieve a particular outcome or output. So, for us we are interested in electric circuit. So, let us see what is electric circuit. So, what is electric circuit? When I say electric, it deals with current. Okay. So, electric circuit basically is the one that will provide the path for the flow of current. Circuit is a closed path for the flow of current. So, this is, for our understanding, circuit is closed path. What does this closed path doing? This closed path is making the current to circulate in it and do certain work. Okay. What is the work done? It depends upon the application. Okay. So, electric circuit is the one that will be providing closed path for the flow of current. Now, I can draw a simple circuit consisting of various elements. Let us consider a circuit given. Let me call this as a voltage source of E volts. Let this be a resistance of R1 ohms, resistance of R2 ohms, resistance of R3 ohms, some capacitance C. Now, this is a very simple electric circuit. Now, it is not only enough for us to know what is the electric circuit alone. There are certain parts of this electric circuit which we should know. Okay. And the first part is a branch. What a branch is? So, branch is the path in the circuit where the current flows. Okay, it is a part of the circuit where the current flows. Okay, so let me first name this circuit. The corners, let it be A, B, C, D, E and F. Let this be the corners of the circuit named. Now, there are various branches in the circuit. AB is a branch, BC is a branch, CD is a branch, DE like EF, FE, BE, all these are branches. So, when I say a closed circuit is carrying the current, it means that the current is carried by these branches, okay, in any direction. It depends upon the polarities of the nodes that will decide the direction of the current in a particular branch. So, branch is the part of the circuit that carry the current. Okay. Then one more term what we need to know is a node, or it is also known as junction. So, it is a point in the network, or it is a point in the circuit where the branches meet. Okay. So, specifically I can say there are two nodes here. Then it may be asked, can A be a node? Can C be a node? Can D or F be a node? Okay. A node in a very specific sense is a point where more than two branches meet, or it is a point where the current gets divided. Okay. If the current is not getting divided, then generally we do not specify that as a node. So, therefore, only B and E will form the node in the circuit shown, whereas point A, C, D or F, these will form the corners because of the orientation. Okay. So, it will form as a corners of the circuit, but not the nodes of the circuit. So, whenever the current is flowing in the circuit, the current gets divided only at point B and point E. Therefore, we call these two as the nodes. Okay. Then there can be a different kinds of circuits, there can be a different types of circuits, there can be a linear circuit, there can be a non-linear circuit. So, a linear circuit is the one in which the change in the input is proportionally observed in the output. It means if the circuit follows superposition principle, then we consider the circuit to be linear. If the circuit does not follow superposition principle, the circuit is non-linear. Now, suppose if voltage, suppose voltage V1 is producing current I1, voltage V2 is producing current I2, then when I give the weighted sum of voltages V1 and V2, if I give say A V1 plus B V2, then it should produce the output A I1 plus B I2. This is the superposition principle. If a circuit follows this principle, then that circuit is a linear circuit, else it is a non-linear circuit. Okay. So, there can be a linear circuit or there can be a non-linear circuit. Likewise, there can be a bilateral circuit or there can be a unilateral circuit. Okay. So, what is bilateral circuit? If the circuit elements connected are capable of carrying current in both the directions, then that circuit is known as bilateral circuit. For example, any passive element like resistor, capacitor, inductor connected in a circuit can carry current in both the directions. Therefore, such circuits can be categorized as bilateral circuit. Circuit with elements, okay, that carry current in both the directions. So, that is called bilateral circuit. Okay. Then unilateral circuit, this is one more type of circuit. So, it is the circuit which have elements that may not carry current in both the directions. For example, the circuits having semiconductor devices like diodes and transistors. A circuit consisting of diode and transistor will not carry the current in both the directions. We know that diodes will carry current only when they are forward biased. So, it means a circuit element consisting like diodes or PN junction components may not carry current in both the direction, and those circuits will form unilateral circuits. Okay. So, these are other type of circuits which we have. Okay. Then what are circuit elements? We were talking about circuit elements. Okay. I told the circuit elements, here we have mentioned the circuit elements that carry current in both the directions. Okay. So, circuit elements are nothing but the components. Circuit elements are nothing but the components or the devices connected, okay, components connected. Okay. What are the components? What are the different types of components what we have? So, it can be a resistor, it can be an inductor, it can be a capacitor, it can be a voltage source, it can be current source, it can be a diode, it can be a transistor, it can be any other, take all in etc. So, circuit element is the component that is connected in the circuit. It can be anything that is receiving the power or delivering the power. Then there are two types of elements we have. In the circuit elements given, there are two types of elements. One is active element and passive element. So, what are active elements and what are passive elements? So, active element is the one that has the capacity to deliver the average positive power. Active element is the one which has got the capacity to deliver average positive power. It means active elements can be considered as sources. Okay. The sources, whether current source or a voltage source, is having capacity to deliver the power out to the other elements of the circuit connected. Okay. So, these active elements will deliver positive average power. In the sense, the power delivered by these elements is greater than 0, okay. Positive average power. Then what are passive elements? Okay. And for example, though the active element may not be the sources all the time, okay, sometimes a oscillator circuit or an amplifier circuit is also considered to be an active circuit. The circuits consisting of operational amplifiers is also at times considered as active circuit, because these circuits are modifying the input signal. Okay. So, there is an activity going on in the circuit, that is either amplifying or attenuating the input signal, or either the shape of the input signal is modified. So, such circuits are also known as active circuits. Okay. Whereas passive circuit elements are the one that do not have capacity to deliver the average power or average power greater than 0. Okay. So, these passive elements generally are the elements that will receive the power input. Okay. So, here to give an example of active element, it can be a voltage source. Example, it can be a voltage source, it can be a current source, it can be an at a times amplifier. So, whereas passive elements are the one that do not possess the capacity to deliver the positive power, or average power delivered may not be greater than 0. Okay. Then what are passive elements? Passive elements are resistors, capacitors, inductors. Okay. So, we know that these elements will receive the power unless and until these are receiving the power from any source, these elements will not carry any current. But when I consider the elements like capacitor and inductor, they have got the capacity to store the energy, and also they can deliver the energy back to the circuit when they are in the discharging mode. Now, can we call these inductors and capacitors as active elements because they are delivering the power, they are giving out the energy when they are in the discharging cycle. Then will this nature of capacitor and inductor giving out the energy to the connected elements make them as active elements? So what we need to understand here is, active elements are delivering the energy in the form of sources, but whereas if you consider the charged capacitor or a charged inductor, it has received some power or some energy from other source, so that the energy is stored across them. If I take an inductor here of a self inductance say L, so the energy stored in this inductor is equals to half Li square. So this is the energy stored in the inductor, half Li square joules. If you take the capacitor of say capacitance C, then the energy stored in this capacitor is half CV square. No doubt these two elements are storing energy, and when a discharge path is provided to them, they will deliver out energy, but the energy what they are delivering in their discharge mode or in the discharge cycle is lesser than the energy that they have received from the previous source. So though these elements are capable of delivering a finite energy, these may not be categorized as active elements, because the energy what they are delivering out when after their full charge cycle, it is not the same energy that it has received. Some amount of energy loss occurs in them to overcome their implicit limitation present. Okay. Therefore, I may not categorize these two elements as the active elements. Okay. So, my active elements generally what we consider in our entire study in this course is voltage source and the current source. Other active circuits like amplifiers and all you may be studying in various other courses. Okay. So, this is all about the various circuits and various circuit elements. So, the major thing what we need to know about the circuits is these two, active elements and passive elements. Passive elements is clear, we need not to further look into what types of passive elements and are there, but now still we need to look into what are the different active elements we have and how these active elements and their equivalences are taken into our study. So, let me take next as sources. So, whatever we have seen so far is about the circuits, types of circuits and types of elements. Now, next specifically we will see what are the active elements in the form of sources. Okay. So, like I told, there are two types of sources. It can be a voltage source and it can be a current source. Voltage sources we all have come across, various voltage sources like batteries. We all use our cell phones, we use cell phone batteries. So, battery is a voltage source. A larger voltage source we can consider as a electric generator, which is giving out a large amount of power to the entire power network. There can be another voltage sources like oscillators for generating a quite various types of signals. Okay. We may be using oscillators. Okay. So, we may be having a regulated power supplies in our practical sessions, you might have observed, that is also a voltage source. So, any component or any element that is giving out the voltage, okay, or that is giving out the energy by keeping its terminal potential constant is a voltage source. Okay. And the other kind of source is a current source, but we might have not come across this current source so far, because it is difficult to visualize, realize a separate current source which is giving out only the current without the voltage. It is not that current source is a source which gives only the current without any voltage. That is not the sense what we have to take it into account here. So, current source practically is characterized by only the current value, but the current source practically is obtained from the voltage source alone. Okay. So, practically realizing a current source is quite difficult. Okay. Any current source we see in any application, that is obtained from again voltage source such that the terminal is delivering a constant current. The best example of a finite current source, okay, what I can give, voltage source we know that I just now I mentioned batteries, okay. It can be in a generator in a larger volume, okay. It can be an oscillator, etc. Current source, how, when you get a current source, when you see a current source, I will go back to the electronic fundamentals. We know that a transistor has got its output characteristics. If I plot a common emitter configured transistor output characteristic, it will be a collector current against collector emitter voltage, IC versus VCE curve. Now, when I plot the characteristic for various base currents, we get a set of curves or a set of characteristics, okay, of this nature. Let me call this as IB naught, let me call this as IB1, let me call this as IB2, so on. And when I mark the operating regions of this transistor, say there are 3 operating regions of the transistor. This is cutoff, this is linear, and this is active. So, we know that in cutoff region the transistor is operating like an open switch or open circuit. In linear region the transistor is operating like a closed switch or a short circuit, and in active region the transistor is operating like an amplifier. Okay, I am making the transistor to operate as an amplifier in the active region. So, depending upon my requirement, I can fix the operating point of a transistor in whichever region I want it to operate. Okay, but we are not here to discuss about the transistor operation. I just want to give you how a current source can be visualized. Okay, that is my fundamental point to invoke the transistor characteristic in the lecture. Now, you can observe in the active region the current is remaining constant. We say the collector current saturates. The collector current saturates. Observe the voltage. If you take this block, this is say VCE T threshold. Let me give a name threshold. Okay. So, after VCE threshold, the transistor output current is remaining constant, okay, irrespective of the voltage across the collector and ground, the current is remaining constant. Now, the transistor is giving a constant current and it is operating as a current source. Okay. So, I can say a transistor can be realized as a current source, a dependent current source. I will come back what are dependent and independent current sources in the active region. Okay. So, this is how generally a current source is visualized in practice. You cannot have the constant current of a transistor without application of the collector emitter voltage. Okay. If I make collector emitter voltage, my transistor current also becomes 0. Okay. So, visualization of current source is in such a way that it is a modified form of voltage source. Okay. So, we will come back again, we will look into how exactly the voltage sources can be converted into current sources and current sources can be converted into voltage sources. Okay. So, this is about current source, a small hint that how practically a current source is realized or visualized in practice. There are 2 types of sources, whether current source or a voltage source. Okay. It is independent source, independent sources and dependent sources. Independent sources and dependent sources. Okay. So, as the name suggests, independent sources are the one whose values, the source value is independent of any other circuit element or any other circuit parameter. Okay. Source value is independent of any other element, any other element value. So, the source value of an independent sources, whether it is an independent voltage source or an independent current source, is not depending upon any other element value. That is, the voltage, suppose I have a voltage source, suppose I have a independent voltage source, then that independent voltage source, the value of that voltage source may not be depending upon or is not depending upon the current flowing or the voltage across any other element. So, that kind of source is known as independent source. Whereas, dependent source, the name suggests, the source value depends on either the current or voltage across any other element. Okay. So, here source value depends on voltage or current in any other element of the same circuit. Okay. Now, just now I told I can visualize the transistor as a current source. Okay. I told I can visualize transistor as a current source in its active region, but is the value of output current IC, okay, is it independent of any other value? No. This IC, the amplified current IC, is always depending upon, okay, the beta IB. So, if I vary the base current, the collector current varies depending upon my current gain beta. So, though this device is operating as a current source in its active region, but the value of output current is not independent, it is depending upon some other current in the same circuit. So, I can visualize the transistor as a dependent current source. Okay, it can be visualized as a dependent current source. These are the two basic type of sources, dependent source and an independent source. So, what are independent sources represented like? Let me take independent voltage source. So, independent voltage source is represented in any of this form mentioned, a voltage of E volts. Generally, we use this notation to show battery. Okay, this is an voltage source, or it can be represented in a circle with polarities marked. This is of, say, voltage E. These polarities can be displayed inside the circle, or the polarities can be mentioned outside the circle. This is also an independent voltage source of voltage E. Okay. Then likewise I can represent independent current source. How it can be represented in a circle with an arrow mark of the current value, say I. If the circle consists of polarities positive and negative, that is a voltage source. If the circle consists of the arrow mark upward or downward, it can be anyway, it is a current source. So, this is the circuit representation of independent sources. It represents, this notation represents independent voltage source, this representation indicates independent current source. Then how the dependent sources are represented? Dependent sources. So, there can be a dependent voltage source, there can be dependent current source, but depending on what? What is the parameter or a quantity that is making the source dependent? These dependent sources are also known as controlled sources. These are also known as controlled sources. Okay. So, I have a dependent voltage source. Let me take voltage source. Then the way how I represent dependent source. Now, I should be able to recognize a given source is either a dependent voltage source or a dependent current source. Okay. So, or whether the given or the circuit, the source mentioned in the circuit is a dependent source or an independent source. Now, to represent independent sources, we use the circle. Now, here to represent dependent source, we use the diamond structure or rhombus. Okay. Now, if it is a voltage source, it has to be mentioned with polarities inside this diamond structure. Okay. So, this is a dependent voltage source, but depending on what? Okay. It is a controlled voltage source, but what is the controlling parameter? So, let me consider, let us take this as C into Vx. Now, what is C? C is a scalar. Okay. It is any scalar quantity, okay, dimensionless scalar quantity, whereas Vx is the voltage which is present across any element, any other element in the circuit. Now, this is a voltage source controlled by a voltage. Therefore, I can call this dependent voltage source as voltage controlled voltage source. I can consider this as voltage controlled voltage source or voltage dependent voltage source, because this is a voltage source which is depending upon the value Vx, where Vx is the voltage across any other element in the same circuit. Therefore, I can categorize this as a voltage controlled voltage source. There can be a voltage source again, when it is voltage source plus minus, and this voltage source, say suppose, is having a value d into Ix. This is a voltage source of value dIx, but it is depending upon the value Ix, where Ix is the current through any other element in the same circuit. Therefore, this representation I can call it as a current controlled voltage source. Current controlled voltage source. Okay. So, there are two types of dependent voltage sources: voltage controlled voltage source or voltage dependent voltage source, current controlled voltage source or current dependent voltage source. Likewise, there can be current sources, dependent current source. Then how to represent a current source? Same diamond structure. Now, to represent voltage, I represent polarity. Now, here I should be representing it with arrow mark. So, when there is arrow mark in the circle or in the diamond, it is a current source. If it is a circle, independent current source. If it is a diamond, dependent current source. Now, the value can be, say, A into Vx, where A is a scalar, Vx is the voltage across any other element in the same circuit. Now, this is a current source of value A Vx, but this value of current depends upon the voltage Vx. Hence, I can call this as voltage dependent or voltage controlled current source. I can call this as voltage controlled current source. Likewise, I may be having one more current source which is controlled by the current. Again, arrow mark in the diamond structure is a dependent current source. It can be, say, B into Ix. B into, say, Ix. Now, the value of this dependent current source is depending upon the value Ix. Just now we discussed about the transistor characteristic. IC is equals to beta IB. Okay, so where beta is a gain scalar. Okay, I can consider it as a scalar quantity, whereas depending the IC is depending upon IB, the base current. So I can consider the transistor in the active region as current controlled current source. Therefore, this is the current source depending upon the value Ix. That is, the current Ix is controlling the value of this current source. Hence, I can call this as current controlled current source. Current controlled current source. So, these are the various types of sources that we come across the entire study in this course. Okay. With this, I will end my session for the day. In the next lecture series, in the next lecture, we will be looking into how these voltage sources and current sources are transformed from one to each other, and what are the various other techniques that we use to reduce the circuit to an equivalent form by using either source shifting or source transformation. Sorry. Okay. So, today I will be closing the session. Thank you.